follow for more chemistry
Hello, my
lectures.
friends. Good day. I remain Dr. D.I. June. In my last video, I discussed D.I. June Formula 1 used in determining the atomic masses of elements with even atomic numbers. And those of you who followed me in that video, you know how we were able to determine some of the elements with even atomic number. And right now, I want to discuss on D.I. June Formula 2, which we use to determine the atomic masses of elements with odd numbers. So that by the time you follow this formula and you remember them, it will not be difficult for you to solve problems involving chemical equation that determines atomic masses if the examiner refuses to provide the atomic masses. It will not be found in any difficulty. So right now, let's go. Formula 2. Now, it goes this way. See it here, atomic number of elements. So the D.I. June Formula 2, which we use in determining atomic mass of elements with odd numbers, is atomic number of elements times 2 plus 1. Now, let us think of the elements from number 1 to 20 that have odd numbers. 3 is an odd number. And the element having 3 as atomic number is lithium. Lithium. Atomic number. Atomic mass of lithium is 7. Which all of us know. Now let us see how we can determine this 7 using this formula. See the atomic number. Atomic number is equal to 3 here. So therefore this 3 times 2 plus 1. 3 times 2 is 6 plus 1 is equal to 7. So we can see that it corresponds with atomic mass. Now the next one, which is odd number, is boron. Boron. Boron is number 5. So atomic mass of boron. Atomic mass of boron, all of us know that is 11. So now the atomic number times 2 plus 1. The number is 5 times 2 plus 1. 5 times 2 is 10 plus 1 gives us 11. 11. So we can use this to determine other ones. Now the next after boron is nitrogen, an odd number. This DID formula 2 does not apply to nitrogen. And also, why? Because some of these elements are isotopes. Even chlorine 2 will not have this because they are isotopic nature. But instead of chlorine, you will get 35, but chlorine is having 0.5. So that 0.5 does not conform to this formula because the two isotopes of of chlorine are what they have found. 25% of one, 75% of one are added to make 35.5. Well, let's go back. So now the next one is, after nitrogen, is fluorine. Fluorine is the number 9 element on the periodic table. So if you multiply 9 by 2, they give you 18, plus 1, 19. So as a chemistry student, you know that atomic mass of fluorine is 19, which corresponds to this DID formula 2. The next one after is now potassium. Potassium is the 19th element. So therefore, 2 times 19 is 38, plus 1, 39. Atomic mass of potassium is 39. So you can see that you can determine the atomic mass of elements with odd numbers with this formula. Now chlorine, which is the 17th element, chlorine's molecular mass is 35.5. Now if you use this formula, if you use 17 multiplied by 2, which is 34, plus 1, 35, you will get the 35. But chlorine has two isotopes. We have isotope 35 and chlorine 37. So it is these two isotopes that the percentages were added. That's why you have 35.5. Otherwise, if we are basing our calculation on only isotope of 35, then this formula will go. But because of the second isotope, which is 37 by atomic mass, due to difference in the neutrons, this formula may not apply. So chlorine has 35.5, while this formula, if you have it, you have 35. The difference is 0.5. So the first 20 elements, as we have said, these two formulas can work effectively. If you can remember them at any given situation, even if you are called from sleep, you are very much capable to say something about it. So other elements from 21 down to the rest, these two formulas are not applicable to them. It is only confined to the first 20 elements, even excepting hydrogen, because hydrogen does not conform to these two formulas. So, fans, we'll stop there for the day. Comment, also share, and also send the video to many of your fans. Share it, and do not forget to follow me on my account for more serious chemistry lectures. Thank you.